Welcome everybody. We've been given the following equations: x squared positive y squared is equal to 7, x cubed positive y cubed is equal to 10. We are asked to find x positive y. This is a very popular question, and we will actually learn how to solve this. I'm going to take this as equation 1 and equation 2, and for this what I'm going to do is I'm going to let x positive y be equal to some cube. So this is going to be my 3. So the idea is we will first solve 2 and 3. Okay, so consider, say, x positive y whole cubed. This is going to be x cubed positive y cubed positive 3 times xy times x positive y, right? So we know this formula. Now since x cubed positive y cubed is equal to 10, I can rewrite this as 10 positive 3 times xy. I've taken x positive y to be as q, and over here this is going to be q cubed, right? X positive y is equal to q. So this is q cubed negative 10 divided by, now what we can do is we can actually split this as 3xy and push this cube down. So this means I got xy is equal to q cubed negative 10 divided by 3 cube. Next we will consider x positive y the whole squared, which is nothing but x squared positive y squared positive 2 times xy. Now my xy is q, so I get q squared there. Now x squared positive y squared, I will just retain it as it is for now, and then I will replace xy with q cubed negative 10 divided by 3 times q. But x squared positive y squared is given as 7, right? So we have q squared is equal to 7 positive 2 times of q cubed negative 10 divided by 3 times q. So from here I can rewrite this as q squared negative 7 is equal to 2 times of q cubed negative 10 divided by 3 times of q. So now what we will have to do is this is 2 times, oh, there is no q there, it's only 2 times of q cubed negative 10. So we will have to perform the simplification. So I will push this 7 to other side. So we have q squared negative 2 times q cubed negative 10 divided by 3 times q of 7. So the LCM is 3 times q. So this is going to give me 3 times q cubed negative 2q cubed positive 20 is equal to 7. Okay, this is what we have got. Now we will have to move to the, probably I will simplify this. So 3q cubed minus 2q cubed, that is going to give me q cubed, and a positive 20 divided by 3 times q is equal to 7. So let me write that down. Q cubed positive 20 divided by 3 times q is equal to 7. So from this we are going to get q cubed positive 20 is equal to 21q. So q cubed, I bring this 21q positive 20 is equal to 0. Now we need to get the value of q. So I will be using synthetic division. Right, synthetic division. So this is coefficient is 1, q squared is not there, 0, q is there, 21, and constant is there, 20. Let me substitute, or let me try 1. I bring this 1 down, 1 into 1 is 1, 1 added with, or 0 added with 1 will give me 1, 1 into 1 is 1, 1 added with negative 20 will give me negative 20, 21 actually, 1 added with negative 21 gives me negative 20, negative 20 times 1 will give me negative 20. So clearly q is equal to 1 is a factor, and the quotient, right, the remainder is 0, the quotient is, we started with q cubed, so now we have to start with q squared followed by q negative 20 is equal to 0. Okay, So this gives me one root. Okay, q is equal to 1. So q is equal to 1. What is the meaning of this? This means x positive y is equal to 1. Okay, so that is the understanding. Now let me solve this one. So I'm going to use quadratic formula. A is equal to 1, b is equal to 1, c is equal to negative 20. So q is equal to negative 1 plus or minus root of b squared minus 4 times a times negative 20 divided by 2. So it's going to give me negative 1 plus or minus root of 1, negative positive 80 divided by 2. This is going to give me negative 1 plus or minus root of 81 divided by 2. There are two roots here, negative 1. Root of 81 is going to be 9. So this is going to be giving me 8 over 2, which is 4. And the other one, negative 1, negative 9 divided by 2 gives me negative 10 over 2, which is negative 5. So the roots are q is equal to 4, q is equal to negative 5. So now we need to move to the next side. So I'm looking for an additional sheet. Okay, let me use paper. So what are the values we got? We got q is equal to 1, q is equal to 4, and q is equal to negative 5. So over here x positive y is equal to 1, over here x positive y is equal to 4, over here x positive y is equal to negative 5. Now we will have to now go back to the question given. Now we have been given this formula, or I would say this surface x squared positive y squared is equal to 7, and then x to the power of 3 positive y to the power of 3 is equal to 10. We've been given this, and then we have taken, and we have x positive y is equal to 1, and then x positive y is equal to 4, and x positive y is equal to 5. We have three values, but not all these three values is going to satisfy the system. Product of the roots xy. Now if you remember, we have this formula that x times y is x positive y the whole cubed negative 10 divided by 3 times of x positive y. This was the formula we obtained. So if I were to substitute x positive y equal to 1 over here, this would give me 1 negative 10 divided by 3 times of 1, and that's going to be negative 9 over 3, which is going to give me negative 3. xy is equal to negative 3 for this case. Now in the next case, so let me write that xy is equal to negative 3. Now for this situation also we need to get xy. So xy is equal to, I'm substituting 4 cubed negative 10 divided by 3 times of 4. This is 64, so 54 divided by 12. Now we can use say 3 divides here once, and you have 2 remainder, 8, and 3 divides here 4, 2 divides here 2 times, 2 divides here 9 times. So xy is equal to 9 over 2 in this case. Okay, now this is the next situation where xy is equal to negative 5 cubed negative 10 divided by 3 times of negative 5. So this is going to give me 125 negative 10 divided by 3 times 5 is 15. So I will have negative 135 by 15. So it's negative, so it's become positive. Okay, so 5 divides here 3 times 5, 5 2s are 10, 3, and you have 7. So 3 divides here 9 times, 9 3s are 27. So over here you get xy is equal to 3, 9, not 3, 9. So I get xy is equal to 9. So these are the product of roots. So now we will obtain the quadratic system, okay, or quadratic equation. Now that is got by this formula: x squared negative of s times x plus p is equal to 0, where s is the sum of the roots and p is the product of roots. Okay, so this is going to be x squared negative. For the first case, sum is 1 and product of the roots is -3. So solve this. So a is equal to 1, b is equal to -1 and c is equal to -3. So x is equal to 1 plus or minus 1 minus 4 times a times and -3 divided by 2 times of a. So this is going to be 1 plus or minus root of 1, 4 times 3, 12 divided by 12. So it's going to be 1 positive root of 13 divided by 2. This is greater than 0. The root is greater than 0. And in this is real. Okay, the roots are real in this case because the roots are real. Okay, so that is a check you need to do in this situation. So for the other case also, the roots will be real and unequal. Okay, the roots are real and unequal. Okay, so in the next situation, x squared negative s, sum of the roots is 4 here, so 4 times x, and the product of roots is 9 over 2. So positive 9 over 2 is equal to 0. I multiply by 2 throughout, so it's going to be 2 times x squared negative 8x. Positive 9 is equal to 0. So minus b, that's going to be 8 plus or minus root of 64 negative. 4 times 2 is 8. 8 times 9 is 72. So divided by 2 times of 2. This is less than 0. So the roots are complex here. Roots are imaginary. Okay, or you can just say complex. Because the discriminant is actually producing a negative component inside the square root. So we need to drop this. X positive y is equal to 4. We need to drop this. Okay, so now let me go to the next one. X positive y is equal to -5 and xy is equal to 9. Okay, we need to check this one. So x squared negative s times x positive p is equal to 0. So this is x squared negative of -5 positive 9 is equal to 0. X squared, this is x, so positive 5 times x positive 9 is equal to 0. So x is equal to -5 plus or minus root of 5 squared is 25, negative 9 fours are 36 divided by 2. So you see here, the roots are imaginary here. Right, discriminant is less than 0. So this means we need to drop x plus y is equal to -4. You need to drop this. So therefore the solution is what? The solution is x positive y is equal to 1. Okay, this is the only solution for this system. X positive y is equal to 1 is the only solution to the given system. So this is how you need to conclude this beautiful question. Thank you everybody. Please like, share and subscribe.